So the first thing I wanted to show you today is WebAssign. I'm surprised that you haven't had WebAssign before, but WebAssign is usually used in the science, PreCalc. I know that some other, physics. I know some other classes use WebAssign, but it's an online grading system, and I don't have internet. That's just great. So I can't actually show it to you. The URL is webassign.com. If you buy the book from the store under my name for Math 111, you'll see, did anybody buy it? So you just get a disc. That's all you get is a disc. And that disc contains a WebAssign code, and it contains, I don't know what else it is. The important thing is that you need the WebAssign code. Once you have that WebAssign code, that proves that you paid for the book. What you get from me is a connection between the book that you bought and me, because it doesn't know whether you're taking PreCalc from X professor at institution number Y. So to connect to me, that's why I gave you a class code. Now when you go to the WebAssign site, it'll say something like new student login. It has some direction there, and it'll ask you for the class code. You put in the code that I sent via Canvas. Once you get on that code, you'll see an assignment show up where you can click on that assignment and you'll be able to work the problems. You can either work them pencil and paper and put in some wrong answers until the right answer comes up as the answer, so if you want to check your work that way, or you can try to type in your answer into WebAssign and see, WebAssign will tell you if it's right or wrong. On WebAssign itself, it has some things on it, like you can go read it and it will send you to the book, an ebook, and it will take you to the site where the information is, and it'll show you how to drag it out and do all the steps, supposedly. And sometimes there's a little watch it, and there's also a practice it button. Those are all things to help you get through the problem if you don't know the steps. The only problem is sometimes the book or whoever is on the video is showing you a different way to do, there's many different ways to do these problems, and they're showing you a different way to do the problem. So if you're finding that it's confusing you, just email me. And what you'll see is I'll post a video for you answering your question. So I've done that already for a student. You saw that. He said, I really need the sound on number 1. I can't figure out what's going on. So I read it and then posted it on YouTube. Questions? I wish I could show you this. Again, something's not working. So I'm going to go through some of the material today and some of the material for, we're going to go through some of the material, but not all of it, so that you can do the in-class assignment. Because it's pretty hefty. So let's start off with a question that someone asked. Oh, I was also asked about whether you need the book. Yeah, you need it. It's $75 to get that WebAssign. The ebook is on it. You have to be able to do the homework and see if your answers are right or wrong. And the quizzes are based off that homework. So if you don't have the book, you have no way of preparing for the quizzes. And reading these slides are not going to be enough. It just won't be. You need to practice some of it and get a handle on it. So you need it. Someone asked me a question about number 10. They said they were totally lost on number 10, didn't have any clue of why. It appeared to them when they were looking at the PowerPoint slides that the numbers were just changing, and he had no idea why those numbers were changing. So I thought I'd explain this problem again one more time with a different approach. So you're asked to find the average rate of change of the function f of t equals sine t from t equals 0 to t equals 3 pi over 2. The average rate of change is found by calculating some change in quantity and dividing by the change in time. So for example, you all are biology majors. I don't really know what you do in your labs, but let's say you were growing bacteria in a petri dish, and you wanted to know what the average rate of change is of the bacteria over a certain period of time. What you would do is you would measure those bacteria in the petri dish at time point 0 and measure it again whenever the professor told you to stop, and you look at how many more bacteria are in that petri dish over that time. That's the amount that I'm talking about. There's an amount that's changing over time. And then you would divide that number by the time elapsed. So you can get a population per minute change. You can get the rate of change this way. We do that for our United States population. How is the population changing per year? So we calculate the same thing. We look at what is in the United States this year, compared to what was in the United States last year, and divide by 1. So that gives us the change per year in the population. Same idea. So I'm giving an example. These examples, because they say rate, they come from distance, speed, all these things come from physics. So if I cover a distance of 30 miles in 60 minutes, my average rate of change is 30 over 60. And you can reduce that to half a mile per minute. So you can do this in your head, and you do it all the time. So everybody understands that. So this is the quantity, that's the elapsed distance, and this is the elapsed time. That's how you divide the two together. Here, what's different is the quantity they give you is an abstract quantity. They don't give you bacteria or anything real. They just say there's a function and it's changing. Pretend like it's bacteria in a petri dish. I don't know, what do you guys do in biology lab? They're long labs, right? It must be something, right? Do you ever count something and do these rates of change? To me, a lab seems a lot more fun than this. So is it? No? I feel like you're getting your hands dirty and doing something. The denominator of the rate of change is the time that's elapsed. That's 3 pi over 2. Because if time is going from 0 to 3 pi over 2, the time that's elapsed is 3 pi over 2 minus 0. And that's why I put that 0 there, so you can get that 3 pi over 2 amount. And I think in class, I had shown you that, let me see. Yeah. I'd shown you that the numerator was minus 1. Because if I take 3 pi over 2 and plug it into the sine function, I'm going to get negative 1. And if I put 0 in the sine function, I'm going to get 0. So the amount change is going to be minus 1 minus 0. So the numerator is minus 1. So then you take the numerator divided by the denominator, change in the amount divided by the change in time, you get negative 1 over 3 pi over 2. And now it becomes a process of changing that as a, reciprocate the denominator and multiply. And that gives you minus 2 over 3 pi. So the question that the student asked was really insightful. He asked, how did sine 3 pi over 2 change to minus 2 over 3 pi? So there looked like there was a relationship with these numbers. It wasn't. I was just calculating. The numerator was the quantity change in f, and the denominator is the quantity change in time. Change in amount over change in time. That's what it is. The reason they want you to do this kind of problem, or why this problem is here, it's leading you up to calculus. Calculus is all about rates of change. That's what we're doing. The fact is that rate of change is not a line usually, although in biology class you probably, have you ever done scatter plots and put a line through it? Right, so you guys are used to putting lines and looking for trends. But in reality, things are not lines. I mean, think of temperature after death decreasing. It may go down as a line initially, but will the body freeze? You just keep going down? What will happen to the human body if the human body dies and you're trying to measure core temperature? Do you expect it just to go down forever? Be a frozen body after a while? Negative 3,000 Kelvin or something? What do you expect to happen? Should stabilize, right? Should go down like this and eventually go like this. That's a curve. That's not a line. So things are not lines, they're curves, and that's what calculus is. It's the rate of change of curves. You're looking at slopes of curves. So they're gearing you up for that with this question, because you'll do a lot of these type of calculations right at the beginning of Calc 1. Okay, any questions on that? Is that clear? More clear? Come on, give me something. If you want extra steps on something, or you don't know how a little step came in, don't think you're the only one who doesn't know it. The person who doesn't know what step you need right now is me. So I might be skipping something that I think is obvious, and it's not obvious. I'd rather fill that detail in. And with the electronic media we have, it's very easy to do. So all you have to do is ask me. But if you don't ask me, we don't have that communication set up. and that becomes a problem that I really need to know. Like when the student asked me this, I realized, oh, that's what it appears like to him. I haven't put enough detail in explaining how I'm calculating these pieces. So it was really insightful for me.